Algebra 2. Today's learning target is dividing radical expressions. Dividing radical expressions. If possible, I need you to divide the radicand on top by the radicand on the bottom and then simplify. So when you have the same index number and you have a fraction underneath the radical, you can actually separate it and do like the nth root of the numerator divided by the nth root of the denominator if it's easier for you to simplify to find the answer. Secondly, if you also can divide a radical expression by rationalizing the denominator, and we did that when we were doing the complex or imaginary number unit. So we can't leave a square root, cube root, any type of radical underneath the division bar. So you're going to rationalize the denominator. You're going to rewrite the problem so there's no radical underneath. Examples, divide the following. 1 divided by the square root of 2. Notice that the numerator does not have a radical. The bottom denominator does. It is the square root of 2. This problem is not simplified. We cannot leave radicals underneath the division or fraction bar. So in this case, number 1, you're going to have to rationalize. To rationalize the denominator, you're going to use the same radical and multiply the entire problem by that same radical on top and on bottom. And remember from the past that when you write anything divided by itself, it is 1, and multiplying any problem by 1 is going to not change the problem. It's still going to be the same question. So that's why rationalizing works. You're going to multiply straight across. 1 times 1 is 1. Square roots of 2. Divided by the square root of 2 times the square root of 2. And recall that when you're multiplying, you do multiply the radicands together. So technically this is the square root of 4. But the square root of 4 actually simplifies, so you want to go ahead and write the simplified version, and that answer is 2. So this problem has required rationalizing. Notice that the denominator now does not have a radical on the bottom. Also notice some things that at the end, to make sure you're finished, you don't want a radical on the bottom. Please do not leave a negative number on the bottom. You don't want like a decimal or fraction underneath the division bar. And recall for the past, you also don't want the imaginary number there because I stands for the square root of -1. So there's 3 or 4 things you always want to make sure that you avoid, and make sure that the problem's simplified, and that way you can give the best answer. All right, example 2. We have the cube root of 15x to the second divided by the cube root of 5x. Notice that the index numbers are the same. Also notice that it's actually separated, divided by, so we can use the rule from the first slide. You can actually turn it into the nth root of that fraction. And this is a type of problem that it would actually benefit you to do so. So I'm going to do the cube root of, and put both radicands into 1. And you definitely want to do this if you know that you can divide this top by the bottom. Looking at the radicand, we can simplify 15x squared divided by 5x. 15 divided by 5 is 3. X squared divided by x. Subtract powers when you're dividing, and you just get x to the first. And so because I've used that rule, now I look at my answer and I see that isn't even a division bar in my answer. And so cube root of 3x is simplified. I cannot write 3 using a perfect cube, and I cannot take the cube root of x and basically break it up into factors. So this is the simplified answer. Okay, example 3. I have the square root of 21 x to the 10th y to the 4th divided by the square root of 7xy squared. Again, because the index numbers are the same and because the radicands I can actually divide, it's probably best to write it as one big radical. Okay, then you're going to drop your square root down. We're going to simplify this piece. 21 divided by 7 is 3. X to the 10th divided by x to the 1st is x to the 9th. Y to the 4th divided by y to the 2nd is y to the 2nd. And again, number 3 is similar to number 2. I don't have a division bar or fraction left, so that is a good thing. But the last thing you always do is check to see if it can simplify. I cannot take the square root of 3, but I can write x to the 9th a different way. So we do want to use what we've learned in the past. So x to the 9th can be written as x to the 8th divided by, or times x to the 1st. And I can take the square root of y to the 2nd, so remember, just drop it down. And then underline the pieces that you know you can simplify. And to finalize this, the square root of x to the 8th is x to the 8th divided by 2, or 4, x to the 4th. And the square root of y squared is y to the 1st. And we have the radical and 3 and x left underneath. So this is the simplified radical answer. Okay, question 4. 3 divided by 2 square root of 3. On this one, notice there's no radical on the top, so we can't use the same strategy we used in question 2 and 3. I do want to get rid of the square root of 3 on the bottom. It's a single term. Notice this is one term. And so a really good way to do that is to rationalize. Again, you want to write a 1 here, but write 1 in a creative way. So to get rid of the square root of 3, we're going to multiply both the top and bottom of the original problem by square root of 3. You also, if you wanted to, you could put the 2 here, but I usually just do the radical because that way I won't have to simplify as much or reduce. Looking at the numerator, I have 3 times the square root of 3. Notice again that this is not underneath a radical, so this is just 3 times the 1. Drop your square root of 3 down. 2 times 1 on the bottom. And the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is just a positive 3. And so I'm going to multiply the 2 that was in the original problem times the 3. Okay, square root of 3 cannot be simplified, so the top is as good as it gets, and the bottom is going to become 6. And then you always want to make sure that you pay attention to the numbers that are not underneath the radical, and if you notice that you can reduce the fraction, do so. So instead of writing 3/6, it would be better if we wrote 1/2. The radical 3 is going to stay on top, and 3/6 is going to become, like I said, 1/2. I'm just going to choose to leave the 1 off. So square root of 3 divided by 2 is the simplified answer to this problem. Okay, now number 5, just making sure you recognize patterns. This one is more like the problems we did on the last slide. We have the cube root of x divided by the cube root of 2. I do have the same index number, and I see a fraction. So I may want, if I can divide the numerator by the denominator, you want to do this. Okay, now I'm writing it down to let you look at it, but we can't divide x by 2. We don't know what x is. So this problem, even though it does look like number 2 and number 3, when you cannot divide the numerator, the radicand on top by the radicand on the bottom, there's really no need in writing it like this. So, plan B. I'm going to have to rationalize like I did on number 4. But we're dealing with cube roots right now. Okay, so watch carefully, because most of the time when we rationalize, when you're first learning it, we always use square roots. And we can use the same radical, and it always works. But please notice what's going to happen when I put this on the top and the bottom. Look at the denominator. Let's go straight there. The cube root of 2 times the cube root of 2 is the cube root of 2 times 2, which is 4. Thinking about perfect cubes, 1, 2 to the third, 3 to the third, and so forth, none of these will divide into 4, well, besides 1. And so this isn't a good answer because I can't leave a radical underneath the division bar in my answer. So rationalizing by doing the same, using the same method I did in number 4, it's not working with a cube root. So with this type, you're going to have to be a little bit more creative. You actually have to think a little bit more on what can I use. I still want to rationalize. What can I put underneath the cube root to make the denominator be a nice whole number? Okay, and so whatever you decide to put here, you must put on top, because remember, this has to be just 1. So the cube root of 2 times the cube root of 2 didn't work. Now you look at your cubes, and you notice that obviously 8's a cube. So 2 times something would give me what I needed. And that's how you have to think about it. So you want to look at your perfect cube list, look at what the problem gives you, and figure out what can you multiply the number that's given to you, what can you multiply it by to end up getting one of the perfect cubes back. And in this case it would be 4. So we want to multiply the top by the cube root of 4 and the bottom as well. Okay, we're going to go straight across. The cube root of x times the cube root of 4. Remember, you can multiply anything together. So you're going to get the cube root of x times 4, which is 4x. On the bottom, cube root of 2 times the cube root of 4 is the cube root of 2 times 4, and that is going to be 8, of course. And since 8 is a perfect cube, it's in the list, this one's going to simplify nicely. Okay, so we're going to go back, we're going to copy the top down. We got the cube root of 4x. The bottom just becomes a nice whole number 2. And then the last thing I would want you to check for is if you can simplify cube root of 4. And that one you cannot. And the cube root of x, when you divide 1 by 3, it does not give you a whole number. And so this is the best answer. That's when you know to stop. Remember, you're checking to see you don't want any radical on the bottom. You don't want this to be a negative number. Just a number can't be imaginary. Also, we don't want a fraction in a decimal. Okay, let's try number 6. Number 6 says the square root of 75x to the 5th divided by the square root of 12xy squared. So I'm going to try to put it in one big radical like we did earlier. Just writing it down so you can visualize. And then I want you to notice that 75 divided by 12 actually is not going to simplify. We can give a fraction answer. We could do that, but it's not going to simplify nicely. You still could go with this plan if you wanted to, because you can divide x to the fifth by x, and then just leave the y on the bottom. But because like all of it doesn't simplify nicely, then I'm going to choose to not do this and back up and try to just rationalize. Okay, so we're going to multiply, trying to get rid of the radical off the bottom. We're going to try to figure out what we can put here on the bottom so that this times this is going to work nicely. Alright, now remember I said that when you do have square roots, you are allowed to use the same number. So 12 times 12 would give me a perfect square. We could use x times x, because if I'm thinking ahead, that's going to be x squared, and I can definitely do the square root of x squared. And this problem has y squared, so I even can do y squared if I want to, because y squared times y squared is y to the fourth. Okay? Or I could even choose to leave the y out. You have all kinds of options here. You just got to pick what you think is going to finalize your answer. So if I do choose to leave y squared out in this part, then I'm still going to be able to do the square root of y squared. So I can do 12x, or I can do 12x y squared. Between the two choices, I'm going to go with just 12x, only because I know that if I do y squared here, I may have to simplify it a little bit further, but you can do it either way. Alright, so now that I've thought about like how I'm going to rationalize, then I'm going to multiply my radicands together. So I'm going to do top times top. It's going to be the square root of, and we're going to do 75 times 12. 75 times 12 is 900. So I'm going to put that on top. X to the fifth times x to the first, add powers when we're multiplying, is x to the sixth. In the denominator, 12 times 12, I'm going to go ahead and write this down, is 144 underneath the radical. X times x is x to the second. And then this first radical has a y squared. This one does not, but we still have to include it underneath. Alright, next step. Let's go to the bottom first. The square root of 144 is 12. The square root of x to the second is x. The square root of y to the second is y. Please notice right now that my denominator does not have a radical, which is really good. Also, it's not a negative number, it's not imaginary, so that's a good simplified answer as of right now. And then you go back to the top, the square root of 900, and you have to decide, first of all, is that a perfect square? And if it's not, what perfect square divides into 900? So I would just type in the square root of 900 on my calculator, and when you do, you actually do get a nice whole number. So that means 900 is a perfect square. It's 30 times 30. And then we definitely can do the square root of x to the 6. 6 divided by 2 is x to the third. Alright, now, before we call it quits, what I want you to really pay attention to also, sometimes this happens. Sometimes you have the same variable on top and bottom, so look for that as well. If you do need to keep going. You need to simplify this. So if I divide x to the third by x to the first, that's going to be x to the second, right? X to the second. X to the second needs to stay on top. So when you give me the final answer, let's do it this way. We're going to put x squared here. And notice that the y is not on top, but it's on the bottom. It has to stay on the bottom. You can't move it. And then the next thing I want you to do is look at the numbers. Like if you can simplify 30/12, you want to do so. And they're both even, so 2 goes into 30 15 times, and 2 goes into 12 6 times. Oh, and you know what? I didn't even choose the biggest value. 3 goes into 15. I need to keep going here. 3 goes into 15 5 times. 3 goes into 6 2 times. So 5/2 is much better than what I did earlier. So we're going to drop the x squared down again. Please remember to keep the y on the bottom. That's where it was originally. And now, after a little bit of work, this would be the best answer. This would get me full credit. And so there's all kinds of things that you got to really pay attention to in order to know if your answer is simplified or not. So don't get in a big hurry and kind of, move ahead without paying attention to what you write down. But notice my answer, denominator 2y, it's as simplified as it gets, so that's a good answer. Alright, now we're going to switch gears. We're still going to do division, but this time I want you to notice that in my example 7, I actually have 2 terms on the bottom. And so because it is a binomial on the bottom, we're going to have to do what we did in the complex unit, the complex number unit. We're going to have to use the conjugate. Okay. And we do that, we use that conjugate in order to get rid of the radical. Okay, so just recall from earlier this year, using just the square root of 3 on the bottom is not going to work. Okay, let me kind of remind you of why I did this in the imaginary number unit. But if I were to just use radical 3, this is what would happen. The denominator would be 2 times the square root of 3. And the square root of 3 times the square root of 3 would be the square root of 9, which is 3. And notice that that still has a radical. So this plan will not work if it's a binomial on the bottom. So when you rationalize a problem that looks like this, you have to use the conjugate. Remember from the past that conjugate means that you're going to change the sign, basically, in the middle. And so the conjugate of 2 plus square root of 3 would be 2 minus square root of 3. And whatever you put on the bottom when you're rationalizing, you must do the same thing on top. You've heard me say this multiple times, but that's because we want this to be just 1. This problem times 1 is still this problem. Notice on top we have 1 term here, and now we have 2 terms here. My advice is always put parentheses around the conjugate. And then drop your division bar down. Let's focus on the top. We have 12 square root of 6 times 2. We're going to distribute. And then 12 radical 6 times negative radical 3. One at a time. 2 times 12. Notice 2 is not underneath a radical. So 2 times 12 becomes 24. We're in multiply mode. And then the radical 6 is going to have to come down with the 24. Then you're going to do 12 square root of 6 times negative 1 square root of 3. 12 times negative 1 is negative 12. Square root of 6 times the square root of 3 is the square root of 18. Okay, we do need to simplify this, but we wait till the next step. Okay, so we just multiply. We're in multiply mode right now. You're going to go to the bottom. We have 2 terms here, 2 terms here. We're going to do FOIL. So first is 2 times 2, 4. Outside is 2 times negative 1 radical 3. That's going to be a negative 2 radical 3. Inside is radical 3 times positive 2. It's going to be a positive 2 radical 3. And then last is going to be this positive radical 3 times negative radical 3. Positive times negative is negative. 1 times 1 is still 1. Square root of 3 times the square root of 3 is square root of 9. But that does simplify. Okay, we'll take care of that in the next step. Draw your division bar. Let's go back to the top. In every single piece, you have to ask yourself the question, can I write this in a better way? Square root of 6. 6 is not a perfect square, and there's no perfect square out there that will divide nicely into 6. So this piece is already simplified. We're just going to copy it back down. Now, 18 is not a perfect square, but 9 does go into 18, and 9 is a perfect square. So we want to write this as 9 times 2. Okay, and then you're going to have you underline like I've been doing in this unit, having you try to do that. So we'll have to come back to that part. Let's focus on the bottom. On the bottom, we notice that these are like terms. They both have the same radical. Negative 2 plus 2 is just 0. And so because it's the same value but opposite signs, they're definitely going to cancel. And so you're left with 4 minus, and then square root of 9 is just 3. I'm going to bring that down. Notice I'm doing one step at a time, so that way I'm less likely to make a mathematical error. Okay, back to the top. We already know this is simplified, so we're going to recopy 24 radical 6. We're going to drop our minus 12 down. And remember that we still have to simplify the square root of 9, which is 3. So that 3 is going to come outside, and it needs to be multiplied by the 12. But then we still have this 2 underneath the radical, so we need to remember to put it at the end. Denominator is just 4 minus 3, which is 1. Okay, last, we're going to recopy, simplify I should say. So 24 square root of 6. Negative 12 times 3, I'm going to go ahead and put that together. That's negative 36, and then drop your square root of 2 down. We cannot simplify 2 anymore underneath the radical. I'm not even going to divide that by 1. Anything divided by 1 is still itself. So this is the best answer. 24 square root of 6 minus 36 square root of 2. Okay, but you can see it takes several steps to get there. Please remember, when you have a binomial, you have to use the conjugate, change the sign in the middle only, and then you'll have to use FOIL method, most likely. All right, we have one more. We'll go through together. On top we have two terms, 1 minus 2 squared root of 10. On the bottom we have 4 plus the square root of 10. You're going to multiply by the conjugate, so 4 minus square root of 10. Okay, remember to always put parentheses around it, especially when there's two terms. And I would go back and do that over here too. Bring down your division bar, one step at a time. We're going to the top, we're going to do FOIL. First, 1 times 4. Outside, 1 times negative square root of 10. Again, notice this is not underneath the radical. So 1 times negative 1 is negative 1. Drop our radical 10 down. Inside, negative 2 radical 10 times 4. Negative 2 times 4 is negative 8. Then bring down your square root of 10. And last would be negative 2 radical 10 times negative radical 10. Negative 2 times negative 1 is a positive 2. Please be careful on signs. Square root of 10 times the square root of 10 is the square root of 100. Multiplying radicals, you multiply numbers in front, and then you multiply the numbers underneath. Denominator, FOIL. First is 4 times 4. Outside is 4 times negative radical 10, negative 4 radical 10. Inside is positive 4 radical 10. And last is positive radical 10 times negative radical 10. Positive times negative is negative. Square root of 10 times itself is the square root of 100. Okay, back to the top. We're going to simplify. These two in the middle have the same radical. And when the radicals match, you want to go ahead and combine these. So negative 1, it's like like terms. Negative 1 minus 8, that would be negative 9, square root of 10. And 10 is not a perfect square, nor is there a perfect square that divides into it. So this is as simplified as that piece gets. Don't forget, we got to drop down at 4. And then over here, the square root of 100 is just 10. Well, we have a 2 in front of it, so 2 times 10, we're going to put 20 in its place. Then we're going to move to the bottom, and we're going to notice that these also are like terms. We're going to combine the numbers in front. Negative 4 plus 4 is 0, so we don't have to worry about those. We're going to drop our 16 down. And then this says minus, drop your minus. And then this piece, square root of 100 is 10. Alright, it's looking more simplified. We go back to the top. We see 4 plus 20. We're going to go ahead and put those real numbers together, 24. And then drop your minus 9 radical 10 down. And it looks like I cannot do anything else in the numerator. That's simplified. Then the denominator, 16 minus 10 is just 6. And then I noticed that the denominator has a nice whole number, so I'm happy about that. This number and this number and this number, if it can be reduced, we want to do so. Okay, so we got one more thing to take care of. What number divides in 24, 9, and 6 at the same time? And that should be 3. 3 goes into 24, 8. 3 divides into 9 3 times. Never change your radical, just copy it down. And 3 divides into 6 2 times. So this is a better answer than the previous one. And I'm going to stop right there. Just be really, really careful on all your steps. Watch your signs, and continue to remind yourself about the multiplication of radicals. And also remember, our learning target today was dividing. And so you're going to have to rationalize, or you're going to have to see if you can write it as one big fraction and use the quotient rule from algebra.